Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When HBr adds to an alkene in the presence of peroxide effect anti-Markovnikov addition, the reaction proceeds via a free radical mechanism. In this mechanism, the bromine radical adds to the less substituted terminal carbon of the double bond, placing the bromine at the terminal carbon and the hydrogen at the internal carbon. This is the opposite of normal Markovnikov addition. Moving on to the next step. Identify the reactive site. The molecule CH2 is equal to CH. CH2, 8Cu has a terminal alkene. CH2 is equal to CH at one end and a carboxylic acid group at the other end. The carboxylic acid group does not react with HBr under these conditions. Moving on to the next step. Apply anti-Markovnikov peroxide addition. In free radical addition, a bromine radical adds to the terminal CH2 is equal to carbon, less substituted end, because this gives the more stable secondary radical intermediate at the internal carbon. The hydrogen then adds to the internal is equal to CH carbon. And for the final step, determine the product. Bromine adds to the terminal carbon, CH2 is equal to, giving CH2Br, CH2, CH2, 8Cu, i.e. CH2Br, CH2, CH2, 8Cu. Why other options fail? Option A, CH3, CHBr, CH2, 8Cu. This is the Markovnikov product, Br on internal carbon, which would form without peroxide. Option B, CH2 is equal to CH, CH2, 8COBr. This would imply reaction at the carboxylic acid group, which does not occur under these conditions. Option D, CH2 is equal to CH, CH2, 7CHBCu. This implies addition of HBr adjacent to the Cu group with retention of the double bond, which is not consistent with the reaction mechanism. Therefore, the correct answer is C. Therefore, the correct answer is option C.